Flutter has a reputation for allowing developers to build beautiful animated UIs, and it's rightfully so. While you can absolutely build everything with just default Flutter classes and widgets, it sometimes gets way too tedious and time-consuming to do so. Let's see how to make implementing even the most complex animations a breeze. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this tutorial, we are going to take a look at how to simplify this kind of a staggered animation by using the Simple Animations package. The code which is currently driving this animation is taken from the official Flutter documentation about animations, so it means it works, it looks really nice, but the problem is that the default way of creating this kind of a staggered animation is just way too long. Sometimes it can get unreadable or really badly maintainable, and there are certainly ways in which this animation, this staggered animation, could be improved, and that's exactly what we're going to do in this tutorial. The fully vanilla default Flutter animation code is available in a Starter project, which you can get from the written tutorial, which is available in the link in the video description. And you should surely check it out, because over there in the written tutorial, apart from the Starter project, you can also find all of the code written in this video, links to the libraries, and overall go through this lesson at your own pace. The Simple Animations package has multiple ways to simplify your animations, but we are going to take a look at only one of them, and that is the timeline tween. If you want to learn more about the Simple Animations package, about its other features, you can check out its official documentation, and the link is available in the written tutorial. Also, just a brief disclaimer, as you can see, we already have a bunch of animation code pre-written in the Starter project, and I expect you to understand the default way of animating stuff in Flutter. So if you know how to animate things, you're good to go. You can follow along with this tutorial. But if you don't, I'm not going to explain it here. However, I do have some prior tutorials of mine in which I have explained the basics of animations in Flutter. So you should definitely check them out from the card in the corner, and also links to them are in the written tutorial too. So what's the issue with the default way of animating in Flutter? Well, for one, as you can see, there is just a lot of animation fields, because we are animating opacity, width, height, padding, border radius, and color of this container contraption, which produces this nice animation in the end, right? It doesn't really matter what we are animating here. It more matters the way in which we are animating, and you can see that the way in which we are animating is just way too long, and I would say sort of on the point of becoming unreadable. But what's worse than unreadable is the bad maintainability of the current code. Why? Because we are doing staggered animations, we need to use intervals. Just as a brief refresher, animations run from 0 to 1. The value which the animation controller produces over time basically changes from 0 to 1 by default. And if you want to have a staggered animation, what you need to do is to create a curved animation with an interval curve, and this interval indicates a fraction in which this particular, in this case, opacity animation will run. So opacity will run only from the beginning of the animation to 1/10 of the animation, because it's 0.1. Then the width will be animated only from 0.25 of the original animation from the controller to 0.25, and so on and so forth. The problem with this kind of interval definition is that if you, let's say, wanted to make the opacity last a little longer, let's say 0.2, so 1/5 of the whole animation length, then if you wanted to maintain the sequence in which the staggered animations are played out, you would also need to bump up the start time of the width animation, so it would become 0.225, and also the end time, so it would become 350, and so on and so forth with every single subsequent animation in the staggered animation sequence. So basically, if you want to change just the initial animation's length in the staggered sequence, the opacity, you need to also change all of the animations which come after it. And this is not good for maintainability. And sure, we could create some fields like, I don't know, maybe double opacity start and say a 0, then opacity end would be 0.1 and so on, and create fields for everything, and then just say that width would become animated, something like opacity start or end, whatever, plus 0.1, and this would be actually sort of relatively defined, because if we changed opacity start, the start of the width would change together with it. But what have we done by doing this? Well, we have added yet another field. So we would again litter the code with more fields, and more fields equals less maintainability and less readability. So we are basically right where we started. So we probably do not want to do this. The way to solve all of these issues is with the simple animations package. So let's go over to pubspec.yaml and let's add it as a dependency over here. And together with that, we're actually going to add another dependency, which is the supercharged package. It's in no way necessary to use supercharged if you use simple animations, but it adds some nice extensions so that we can write less code for specifying durations. That's the only reason why we are adding supercharged. And also, if you want to get all of these dependencies and their versions and just copy them to your project, you can get them from the written tutorial. So let's briefly go over what we are doing in the default Flutter approach for animating staggered animations. We first, for every single property that we want to animate, we create a tween. We specify the beginning and end of the tween, and we do this whether that tween is a double tween, or we are even doing edge inset tween or color tweens. It doesn't matter. We always have a tween first for every single property that we want to animate. Then we animate or drive this tween with a curved animation, which has an interval curve. And also we set the parent to the animation controller, because there is truly only one animation, the one coming from the animation controller, which drives all of the staggered animation. We just slice that single parent animation up through the use of intervals so that it becomes a staggered animation. And then also for each and every property, so that it looks more smooth, we also set the curve inside the interval curve to be curves.ease. So this easing happens on the fraction of the original animation. In this case, the ease happens on the 0 to 1/10 of the original animation during the interval. But the simple animations package comes with a timeline tween. And with the timeline tween, we are going to have a single top-level tween which will encompass all of the individual tweens. This means that we are no longer going to have all of these animations. We're going to have just one animation which will encompass the animation for every single property. We're basically going to create sort of a container class which will hide the mess from the general code. The mess will be hidden so that our code which we use all around the app can remain clean. We're going to create a container class of sorts. And as if that wasn't enough, the timeline tween also has a very nice way of handling relative intervals. So this means if we change our mind in the future and we want to make the opacity animation last longer, the animations coming after it in the sequence are going to be automatically modified to come after it, even though we're not going to touch their code. So basically, the maintainability of the project will be vastly improved. Since we'll now have a single timeline tween to encompass all of the individual property tweens, we need to have a way to tell which property the tween belongs to. Basically, we can do this with an enum. So let's create an enum all the way up top, like this. It's gonna be called animprops for animated properties. And we are animating, well, opacity, width, height, padding, border radius, and color. So basically we can say that we have moved the field names of the animation fields into the enum, which we have just defined. With this enum created, we can now delete all of the animation fields because, as I've already said, now they're going to be concentrated into just one field, which will hold a container class for all of the individual animated properties. Of course, this is going to completely break the code, but that doesn't matter. Let's also delete this from here. So all of the initializations are going to be deleted, just like that. And of course, the code is broken completely everywhere, but for now, that's just fine. And also, if you want to get the code, which I have pasted here, the enum, you can get it from the written tutorial. So now we're going to have just a single animation field, and its generic parameter will be timeline value. Timeline value is produced by the timeline tween, and it's just simply a container class that's going to contain the values of all of our animated properties. So we're going to say a timeline value of animprops. And let's call this animation an animation. Timeline tween handles staggered animations with scenes. A scene defines a span of time in which the properties being animated within that scene are going to be updated with new values. So a scene is in a way like the interval curve, which you could have seen from the default Flutter approach, but a scene can be used to animate multiple properties, not just a single one. So this results in less code duplication. And since we have previously had multiple intervals with different start and end times, we're also going to have multiple scenes. And let's start with the first one for animating the opacity property. So we're going to set the animation field to be equal to timeline tween, and it's going to have just an empty constructor, and immediately we want to say dot add scene, and the first scene will begin at the very beginning, so that means 0 milliseconds, because actually, unlike the interval curves, scenes take in a duration, not just a simple double. But even though it's a duration, it still behaves more like a fraction of the original animation's controller length, is just not the double, it's the duration, but the principle is still the same. If you change the duration of the animation controller's animation to, for example, be twice as long, so 4000 milliseconds, the scenes will be automatically prolonged as well. So that's not an issue. But anyway, we want to say 0 milliseconds to be the beginning. So we could do duration and 0 milliseconds, but actually we're going to use the supercharged package. So because unfortunately extensions are still not able to be auto-imported as of now, I think we should import them manually. So let's say supercharged, and we're going to import supercharged.dart, the whole thing here. So we can then say 0 milliseconds, and also we set the end time to be 100 milliseconds. We're just copying the previous code over to the timeline tween of doing things, but the animation sequence and length will remain the same as with the previous code. And also we should set curve to be curves.ease, so that everything remains the same as previously with the default Flutter approach. All right, so with this done, we have just added a scene which acts as an interval, but now we need to tell what actual properties we want to animate within this scene. So we're going to say animate. We're going to name the property which should be animated within that scene. So that's going to be gotten from an animprops, the INA which we have created, animprops. And over here we want to animate the opacity. And then we need to define a tween just for this opacity. And just like previously, it's going to be a tween of doubles going between 0 and 1. Cool. And of course, this code is not yet functional, but we're actually going to get to it working in the end. It's not functional yet because the animate returns a timeline scene, but we actually want to somehow turn all of this timeline tween definition into an actual animation. Before we do that though, let's talk about the scene which we have just added. Because if you take a look at it, it's defined in absolute terms. It has a beginning, it has an end, it's absolutely defined in milliseconds, but I have been talking about relative scenes. Well, actually, it's completely fine that the first scene is defined in absolute terms, because after all, it's the first scene, but it's more about the other scenes which come afterwards, after the first scene, that they should be defined relatively. And that's exactly what we are going to do. We can do that by calling .add subsequent scene. Add subsequent scene is a bit different than just the regular add scene call, because this one does not have a beginning and end. It has only a duration of the scene and a delay, and that's it. We are now going to animate the width property, and this scene should have a delay from the previous one of 25 milliseconds. It should be long, so it should have duration of 125 milliseconds. And the curve will again be curves ease. And then the property which we want to animate in this relatively added scene will be gotten from, again, the animprops, and it will be the width and the tween. Tween will be beginning at 50 and ending at 150. Before we go any further, all of the other scenes are going to basically look very much the same. Just you should know that you can actually animate multiple properties on just a single scene. So we could, for example, animate the height or any other property inside of this scene, which runs from 25 milliseconds after the previous scene for 125 milliseconds. We are able to animate any kind of a property we want within this scene, and we can animate even multiple properties in here. But basically, the principles remain the same for all of the subsequent code, which I'm just going to paste here, copied from the written tutorial. But what's more important than that is to show you how to actually turn this value timeline scene returned from the animate call into an actual animation with which we can work from the Flutter UI. And this animation will hold the container class timeline value, which contains the values for each and every single one of the animated properties. So the way we can turn the returned type from here into the animation object with which we can work from default Flutter is by getting the parent, which is the timeline tween, and then from this timeline tween we want to call animated by, and it's animated by the animation controller, like this. Right now we can finally also format the code so it's more readable. Looks good. It's good that we can actually chain these calls and create relative scenes, but it can also become a bit unreadable what's going on here. So there are multiple ways to keep the code more readable as you add more scenes and animate more properties. You can split this up into variables and do it like that, but you can also remain with the fully chained approach, just have method calls without any intermediary variables, and you can just simply add comments. So I would add that this scene is for opacity only, this relative scene is for width only, and so on and so forth. You would indicate which properties are being animated in which scene. But again, you can choose the break it out into a variable approach, but I think that just having comments makes this much more readable in itself. All right, now I'm just going to copy and paste the code, the rest of the code, the rest of the animated properties into here from the written tutorial and save that. Basically, there's nothing new for you to learn from this pasted code because we're still doing the same thing. Actually, this should be removed. The only thing which we have added here is that we are now animating also the height and padding in a scene. So as you can see, we are animating two properties inside of the same scene. And then we also animate border radius and color, but basically there's nothing new to learn from here. It's all just add subsequent scene, then .animate, we select the property which we want to animate, and that's it. And also specify the tween, for example, color tween in this case. The last step which we are going to take is that we now need to fix the code which is responsible for rebuilding the UI using the animated builder. So the UI using the animated builder is rebuilt in this build animation callback method. Currently, it uses the old way of accessing the animated animation values when we still had multiple animation fields. But since we now have only one animation field which holds the container class, we now need to access the individual values from that container class. So we can do that by saying animation dot value dot get, and we want to get the value for anim props dot padding, right? And we can actually remove this thing over here fully. Now let's just copy this, and we're going to change the calls also for the opacity. So we want to get opacity, we want to get width and height. So width height, and lastly color. And it's going to all work, which is fine. So this is color. And lastly, we have the border radius. And after we change this, there should be no errors inside of the app. Yep, there are 0 errors. But just for good measure, let's hard restart the app fully so that it's truly fully restarted, not just hard reload it. And let's open up the emulator. And we see an issue. So let's actually resolve this issue. It's interesting. So what has happened? Well, I've done some mistake apparently. So let's see. Inside of init state, what we have done is that I think I have forgotten to say or to tell the timeline tween the generic parameter. So basically we are having a timeline tween of anim props like that, right? And I think that after I save this and actually hard restart, because we are inside init state, and go and open up the emulator, we now still have some minor issues in here because we have done, or I have done, the mistake of defining tweens without the decimal point. So this is always a good thing to keep in mind, that actually you need to put this decimal place after the number, because otherwise it's going to think that it's an integer tween and it's not going to want to be casted to a double. So it's not great that I've made these mistakes, but you should just keep them in mind because they really can happen anytime, and you're going to be searching where the error is, and actually the error is only in the not including a decimal place afterwards. But now, let's again hard restart since we are inside init state. And now when we open up the emulator, it should all work just fine. So let's tap it, animates, let's tap it again. It reverses the animation and it's looking great. And that's it for this tutorial. To go through it at your own pace once again and to also get all of the code, check out the written tutorial available from the link in the video description. If you don't want to miss more tutorials like this about animations, about simplifying animations like we have done here with the simple animations package, and many more Flutter topics, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, link is also in the video description by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. If this video helped you, give it a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.